Hi there everyone. Today let's take a look at linear simultaneous equations. So linear simultaneous equations are the most basic and the easiest simultaneous equation questions that you'll get. So the easiest way to explain this is to start off with an example. So let's say that the question is x plus y is equal to 3 and 2x plus 3y is equal to 8. Now, remember before this, the types of equations we were solving were equations like, say, 3x plus 1 is equal to 7, for example. And these types of equations here, these are easier because there's only one thing that we have to solve. In this case, that's x. But in simultaneous equations, there are more than one thing to solve, oftentimes two. In this case, it's x and y. So they will give you a pair of equations here, and your goal is to find sort of like pairs of these solutions for x and y that satisfy both of these. So how do you approach a problem like this? So let me label this 1 and equation 2 to start with. Now, the easiest way to do this is to isolate either the x or the y in one of the equations. So let's take a look at equation 1 first. So we know that x plus y is equal to 3. And because of that, we know that x is simply 3 minus y. So now we already know what x by itself is. So we have equation 2 here, which is 2x plus 3y is equal to 8. This x here is the same x as over here. So what that means is that we can just substitute one into another. In this case, since x is equal to 3 minus y, here we simply have 2 times 3 minus y, since that is x. So we're just putting this x value into this x value here. After that, the rest of this is the same. And you can see why this is helpful already. So let's expand this bracket to start with. So we have 6 minus 2y plus 3y is equal to 8. And this is good now is because we only have one variable here to solve, so that's y. So we have a 2y and a 3y. So we know that negative 2y plus 3y is simply equal to y. And you can subtract 6 from both sides as well, so you get 2. In fact, let me actually do that for you. So what we're doing here is that firstly, we can subtract 6 from both sides. So that gives you negative 2y plus 3y is equal to 8 minus 6, which is basically 2. And we know that negative 2y plus 3y is simply equal to y. So we know that y is equal to 2 already. So that's one part of our solution. Now we have to figure out what x is. So now that we know that y is equal to 2, we can put that y into this one. So it's the same thing. We're substituting the value of that in here. So we know that x is equal to 3 minus 2 now because y is equal to 2. And we get that x is equal to 1. So our final pair of solutions, so our final answer here is going to be x is equal to 1 and y is equal to 2. And in this case, this pair happens to be the only solution to this simultaneous equations question. Let me give you a few more examples to make things a little bit clearer. So the next example here is 3x minus 2y is equal to 9, and 2x plus 3y is equal to 19. Alright, so in this situation, we can do the exact same thing except it's a little bit more complicated. So here we have 1, 2. So firstly, let's rearrange equation 1 to get only the x's or the y's on one side. In this case, I can simply add 2y to both sides, so I get 3x is equal to 9 plus 2y. And to get x by itself, I can divide both sides by 3. So I get 9 plus 2y here, and then divided by 3. Oops, not 2, 3. I must be drunk. Oops. Definitely drunk. Divided by 3. And for equation 2, now that we know that x here is equal to that, we can once again just substitute that into this x. So this x here is the same as this x, just like before. So what do we have? We have 2 times that x value, which is 9 plus 2y divided by 3 plus 3y. And this here is, again, still equal to 19. Okay, we're almost there. Now let's just expand this bracket again. So we get 18 plus 4y divided by 3 plus 3y is equal to 19. Now, one problem we have is that there's a fraction here, and fractions are ugly. So we can multiply everything by 3 to get rid of the fraction. In other words, we're multiplying both sides by 3. So what you get here is you get 18 plus 4y plus 9y is equal to 19 times 3, which is 57. So again, we're just multiplying all the terms by 3 to get rid of that fraction. And finally, we can subtract 18 from both sides. So minus 18 minus 18. We get 4y plus 9y is equal to 57 minus 18, which is 39. And 4y plus 9y is equal to 13y. So that's equal to 39, and we can divide both sides by 13 to get y is equal to, it's equal to 3. So that's the first part of our solution. So we know that y is equal to 3 already. Now let's get back to this part over here. Since we know that this y here is 3, so we can just substitute that in. So we get 9 plus 2 times 3 divided by 3. And that is equal to 9 plus 2 times 3 is 6 divided by 3. So that's 15 divided by 3. And that is simply equal to 5. So we know that x is equal to 5 and y is equal to 3. So our final answer for this question is x is equal to 5 and y is equal to 3. And again, for this particular question, this also happens to be the only pair of answers that satisfy those two equations. So hopefully after this video, you have a better idea of how to approach simultaneous equation questions. And that's pretty much it for this video. I'm trying to keep it short. So thanks for watching and have a great day.